Hello, learners. Today we are going to do this question. This is started from the question paper, that is Physical Science Paper 1, that is November 2016. We are going to do question number 2, which is always Newton's laws. So let's do this question. Let's do it. Let's start with the statement and underline or highlight the most important parts of the statement. A learner constructs a push toy using two blocks with the masses. So we have two blocks, which is 1,5 kgs and 3 kgs. The blocks are connected by a massless rod or cord. There is a cord. The learner then applies a force of 25 at angle 30 to 1 kg, 1,5 kg block. Okay. So by the means of a light rigid rod, causing the toy to move across the flat rough. So that rough tells us that there is a friction on the surface, which means we have the frictional force. Okay. Now, before you answer the questions, it is wise to first draw the free body diagram for both objects. In our case, we have 3 kg object and 1,5 kg object. Let's start with this one. Okay, so we have the normal force, then we have the weight, we have the kinetic friction because this one is moving. You also have the forward force, which is a tension on the rod, on the cord, with a tension. We also have a tension that pulls 1,5 kg. Then we have the normal force even here. We have the normal force. Then we have the weight. Then we have the force that is applied. This force is downwards, is in this direction. So that is the force that is applied. So we also have the friction here. We have Fk here. So this is the first thing that you need to do, is to draw the free body diagrams. So we have the free body diagram for 3 kg object. This is the free body diagram that we have. We have the normal force there. We have the weight, that is Fg. Then we have the tension. Then we have the friction, that is Fk. So we have 1,5 kg. Then we have the normal force, then we have Fk, then we have Fg, then we have the force that is applied at 30 degrees, that is applied force, or you can just say F. Now it is important to draw the components for the force. So we have the horizontal component, which is Fx. Then we have the vertical component, which is Fy. Then it is important to remove the original force. Then you have this free body diagram now. Okay, we have this free body diagram and this free body diagram. Okay, now let's continue with the statement. They say the coefficient of kinetic friction for both blocks is 0,515. So we have the coefficient of kinetic friction for this one, that is coefficient of kinetic friction, which is 0,15. that is 1.5. Then we have the coefficient of kinetic friction here, which is equal to 0.15. Okay, now let's go to the questions. The first question says, define the Newton's second law of motion in words. Then you get 2 marks. So when you define this one, you must make sure that the keywords are there. That is, acceleration is directly proportional to the force that was applied. Then acceleration is inversely proportional to the mass of an object. You must make sure that on your definition this is there. Okay, that is directly proportional and inversely proportional. That is your definition. So your definition will be like this: when you apply the force, in fact, when the net force acts on an object, the object will accelerate in the direction of the force with acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. Okay, then you get 2 marks. Once you miss one of these words, you will get no mark. You will get 0 mark. So you get 0/2. It's either you get 2/2 or you get 0/2. So you need to be careful. Now let's go to question 2.2. Calculate the magnitude of the kinetic frictional force acting on 3 kg block. But we are going to calculate the frictional force on both objects. Okay, so let's start with 3 kg block. There is no specific word. Okay, in fact, when we calculate frictional force, we use this formula, which means we need to know the normal force before we calculate the frictional force. When you calculate the frictional force, you must just say, you must consider first the vertical forces. So in our case, we have 2 vertical forces. To make it easy, since we are calculating the normal force, always just say the upward forces are equal to the downward forces. In our case, we have only 1 upward force and 1 downward force. Let's look at 1.5 kg block. I said upward forces must be equal to the downward forces when you are calculating the normal force. In this case, we have 1 upward force and 2 downward forces. Then you calculate the normal force. Let's start with this one. The weight is calculated by mg, which means in this case the normal force is mg. So let's substitute. So it's 3 times 9.8. 3 times 9.8. Then we press the calculator. The answer is 29.4 newtons. This is the normal force. Then we substitute it here. So Fk will be equal to 0.15 times the normal force, which is 29.4. Then we get the friction, which is equal to 4.41. So we have the friction, which is 4.41 newtons. Then the following question says calculate, or in fact we said let's also calculate the frictional force for this one. So Fk is equal to mu k times the normal force, which means we need to calculate the normal force for this block. I already read the formula that you can use. The upward forces are equal to the sum of the downward forces, which means the normal force in this case will be equal to Fy. Fy is F sine theta plus Fg, which is mg. Now let's substitute. The force that was applied on this object was equal to 25 at 30 degrees. So the force there is 25. So we have 25 sine 30 plus the mass is 1,5 times 9,8. So let's press the calculator. Then the answer is 29,20. Then let's substitute here to get the friction. So Fk is equal to the coefficient of kinetic friction 0,15 times the normal force, which is 27,20. Then we press the calculator there. Then we get the friction, which is 4,08 newtons. Now the question can say, or in fact, let's go to the following question. The following question says, calculate the magnitude of what? Of kinetic frictional force acting on the 1,5 kg block. We did this already. This is what was asked, this one. Okay, this is the frictional force of 1,5 kg block. Okay, now let's go to the following question. The following question says calculate the tension, right? Now let's calculate the tension. So if you can look here, we have the tension on the first object, which is a 3 kg block. Then we have a tension on the, where is the tension? There's supposed to be the tension here from the free body diagram. There is a tension. Now let's go up and then see. Here is this tension. I just forgot to include on the free body diagram. So we have the tension on this, that is the tension, and we have the tension, which means what we need to do is to focus on each. Let's start with this one. Then here with the tension, which is the horizontal force. Now let's start with this one. So let's take right as positive, which means left will be negative. Even here, left will be negative, but right will be positive. Okay, now let's calculate the tension. There is no formula for the tension, but since there is no formula, we're going to use F net is equal to MA. Then the net force is made up of a tension, which is positive, minus the friction, which is negative, which is equal to MA. Now the focus is on 3 kg block. Then the tension is what we're looking for, but the friction for 3 kg is 4,41, which is equal, the mass is 3. We don't have the acceleration. Therefore, we have two unknowns, which means this is our first equation. We have tension and acceleration. So we have two equations. Then let's go to object 2. Even on object 2, we're going to say F net is equal to MA. Let's go. On object 2, we have Fx and friction and tension. So we have Fx, which is positive Fx, but minus friction, minus tension, which is equal to MA. Now Fx is F cos theta, Fy is F sin theta, then minus the friction here is 4,08, minus the tension is what we are looking for, which is equal to, the mass is 1,5, acceleration is not given. So let's press calculator here. Or before we press calculate, let's substitute. The force is 25. At which angle? At 30 degrees, minus 4,08 minus tension, which is equal to 1,5 acceleration. Then let's press calculator here. Then here we get 17,57 minus tension, which is equal to 1,5. That is equation number 2. We have two unknown, tension, acceleration. We have a two unknown here, tension and acceleration, which means we can solve them simultaneously. So we have equation 1, which is t minus 4,41, which is equal to 3a. That is the first equation. Then the second equation, let's just make sure that t is the first term here, so it's minus t because the t is negative here. Then this one is positive, therefore plus 17,57, which is equal to 1,5a. That is equation 2. In physics, let's just use elimination or addition method. So we have equation 1 plus equation 2 always in this topic. We have equation 1 plus equation 2. Tension minus tension is 0, so we get 0 there. Then minus 4,41 plus 17,57 is equal to 13,16, which is equal to 3 plus 1,5, that's supposed to be 4,5. Then we divide by 4,5 both sides. Then we get the acceleration 13,16 divided by 4,5. We get the acceleration, which is 2,92 meters per square second. That is the acceleration, but the question said calculate the tension. We will take one of the equation. We can take equation 1, we can take equation 2 to solve t. So I ought to take equation 1, t minus 4,41 is equal to 3a. Then in place of a, I will substitute by 2,92. So t minus 4,41 will be equal to 3 times 2,92. Then we get the tension, which is required. I'm going to transpose this one, then I press the calculator and I get the tension. Let me press the calculator. Then the tension is 13,17 newtons. The question is answered. This is the last question. Please follow me on Facebook. Make sure that you subscribe on this YouTube channel, and make sure that you follow me on Facebook. If you have a question, just inbox me on Facebook. I will try to help you on any topic, grade 10, 11, 12 physical sciences. You can also ask question on mathematics. I will help you. Please share the video to your friends. Thank you. Goodbye. See you on the next video.